All right. So in the series of rational expression, we are focusing our attention for the domain. Now, if I say that before I actually jump into the rational expression, I will ask you one thing. What is 0 over 5? 0. What is 0 over 9? 0. What is 0 over 105 is still 0, so on and so forth. So you know that if numerator having the 0, and of course you can make many combination, negative, positive, variable, everything, it is still 0. Now check what is 7 over 0. So if you punch these numbers in calculator, it will tell you undefined or error or cannot be done. All right. So what happens here is that denominator is 0 is not acceptable. So denominator turning 0 is not allowed. Okay, because it will blow the function. Now let's transfer our discussion towards the algebra. If I give you a function f of x, if I give you a function f of x, and if I say that this is f of x is 3 over 7x minus 14, and I want to determine its domain. By the way, domain is nothing but the values sitting on the x-axis. Okay, values sitting on the x-axis. Now, if you see here by a trial and error, you can select any value of x, and you can find out the corresponding value of f of x. So there are three options. Either this function will turn negative, 0, or positive. Okay, so all the options are valid. The only thing is that I should not have denominator as 0, and we want to eliminate that value. How we are going to do that? When you will land up with such a question and they ask you, hey guys, determine the domain in the given function, what do you do? That you forcefully equate the denominator to 0, add 14, add 14. So it will give me 7x is equal to 14. Divides by 7, divide by 7, and x is equal to 2. All right. So x is equal to 2 point is the point, is the nasty guy. It will make this function. What will happen if I take f of 2, then 3 over 7 times 2 minus 14. So it will be what? 14 minus 14 and 3 over 0, and which is not possible. Not possible. So I want to avoid this point. Okay. And in the domain range, in the domain side, how I'm going to denote is that I will have 2 brackets. X can take all the values starting from negative infinity to positive infinity, but this 2. Okay. And why I left a gap is because you have to make a union. You have to make a union. Okay. So union means what? All the values, the function will work happily from all the values of x starting from negative infinity to positive infinity, but not at 2. Okay. Number 2. If I have a function f of x as x minus 6 and x minus 8, I gave you x in both the sides. I don't care about x in the numerator. X can take any value in the numerator. So what I will do is that I will forcefully equate denominator to 0 plus 8 plus 8. X is equal to 8, and this is the point which I want to exclude. Okay. How do I define the denominator? Domain of this is minus infinity to plus infinity except 8 value. And don't forget union sign. Okay. Done. Question number 3. Number 3 would be f of x is x plus 13 over 5. Okay. In this case, if you get this kind of function in the exam, you are lucky because there is no x sitting in the denominator. So practically, x has no constraints. So the domain for x in this case would be simply negative infinity to positive. Okay, so x has no issues here. And 4. Let's say, why should I take g of plus x over x squared minus 4x plus 3. Am I correct? Yes. Now forcefully equate denominator to 0. 0. Okay. The factors for this is x minus 1, x minus 3 equal to 0. So it will be what? X minus 1. Either x minus 1 equal to 0 or x minus 3 equal to 0. So x is equal to 1 or x is equal to 3 are the bad guys. Now I will rewrite the above equation with 3 over 3 plus x over x minus 1, x minus 3. Okay. Now remember here, if you get one value of x, how do you remember in the exam? If you get one value of x, you have the two parentheses for domain. You have two values of x, your domain will be little bit longer. And how I'm going to incorporate everything? So I have a domain, always one ahead. Now x can take all the values from negative infinity to positive infinity. Now it will take but these values, right? 1. So whatever comes here should come here. Whatever comes here should come here. Okay. So you see here, this is matching, and let's say this is matching, but don't forget, as usual, the union sign. All right. So this is all about rational expression series 2. In the further video, I will discuss about rational expressions, finding the least common denominator. Okay. So see you in the next video. Bye bye.